Okay. Stream started. Class is on. Headphones on. Mic appears to be working. And let's start some music. Hopefully VLC is kind to me today. And when I hit next, it won't do the dumb thing. It didn't. Aw, how nice. Hey, Teeny, you're fast. You're fast getting in here. Aw, Droner around the crew. Yeah, I don't know how long I'm gonna have. There's different things going on. This is like an extra. But we're gonna see if we can just finish up this array list because all we have is remove at, you know? The fraud. How's it going? It's Saturday, baby. I don't care about clients on Saturday, you know? We'll pretend I care about them other days of the week, right? But today, I really don't care about them. Okay. You should put that on your CV. I feel like it's pretty clear. I feel like it's pretty clear when people talk to me, you know? It's yeah, sorry. If you're looking for somebody that is going to care about customers on a Saturday, I don't know if this is a good fit. Thanks. He's a little terrible, but you know, that's how small dogs go, right? But he's mostly a sweetheart. Cool. Now, because I don't like to make anything easy on myself, so I have a split keyboard, you know, by the way. And I just use QWERTY. I'm not a Colmac guy or anything, or Dvorak or any of those. I just use QWERTY bindings. But you know, do I have a link for the repo? I really should put it in here, right? Do I not? Do we not have like... Oh. Nope, I didn't do that. I probably should have. I'll just post it in here and maybe I'll remember. Yeah, so because I don't like to make things easy. No, it was actually because so QWERTY in general is left-hand heavy, at least if you're typing English. And probably true in a lot of languages that use the same alphabet. Did I fix the audio? It should have. Do you think it's fixed, Teeny? I have tried. It should be in sync. I've been meaning to ask you about it. Sweet. Give me 1 second. Speaking of lots of things going on. Okay. We're almost there. So anyway, I don't know if I ever actually finished my sentence about the keyboard, but basically the point is I switched my space and enter keys because my space was on my left hand. Here, this will make more sense. Give me a second. This will make more sense. Okay. Because right now, I realize I'm not making a lot of sense. and we have this special thing called, you know, a web browser. So anyways, I have an Ergodox.exe. I've had it for 7 years, and this was my old layout, which doesn't make sense because it probably doesn't look nice. But anyway, the point is, I just switched this and this, so it's a lot of, yeah, Ergodox, by the way. So that's a lot of years of muscle memory that I'm fighting against. I just changed it yesterday. I was sending messages to my partner, and I ended up just sending, you know, single word messages. It was pretty great because I was hitting enter instead of space. Yeah, it's like it's more ergonomic. I'm actually planning on getting an upgrade eventually, but like, oops, I already did it again. Let's see. Oh, that's their new one. They should have. So the Ergodox.exe was via ZSA's first keyboard. So this is what it looks like. That's almost the exact model I have, except I have an older one that doesn't have shine through keys. It's nice. It's nice. I think concave is going to be better, but you know, mechanical, blah blah blah. It's a cool, you know, 380 or something like this. Yeah, so a lot of reasons. Let's see. Do I want to do this? I'm gonna try this. I might regret it. Let's see. We're gonna try to. Can we get the webcam on the keyboard? Not really. Barely. Move it back a little bit. All right. But you can at least see my hand position. So basically, I can keep my arms shoulder width apart instead of in like this, like if I was on a laptop keyboard. And so it's just a more natural position. We have a little bit of tilt, so my hands are in a, you know, I'd like more of a tilt. I'd like it to be more like this, but right now I'm a little bit of a tilt, which is a little bit more of a normal position. And then, let's see, wrong way. And then I also have a vertical mouse for when I use such a thing. Yeah, it's a little bit over the top. Yeah, it's basically, I had carpal tunnel before I got my first coding job. You know, it's not real bad, but it's not great. So this is like, there we go. I think that's about right. Maybe a little lower. Gotta try to get the full beard in there, you know, it's important. Yeah, so that's basically the idea. I'm considering going to the Kinesis Advantage 360 or something like it. And so it's still split, but this has kind of the concave, and basically it reduces your finger travel. Don't worry about this. That's nothing. No. Yeah, so the Ergodox.exe, the way I configured it when I bought it, it was like 380. And so this guy's pretty cool. This is 480. But yeah, it's money. It is money. So anyway, keybs. I'm gonna get a keyboard cam soon. I just haven't done it because I have to buy one. I don't have an extra webcam lying around. Okay. Shall we code? Shall we get back to the coding? Yeah. That's the 500, the Kinesis there. That's what the Primogen uses. God, the glare on my screen at this time of day hurts me. Yeah, it takes some getting used to, Droner, for sure. Like the split keyboard thing. It takes some getting used to, but for me it's been amazing. Like I said, I mean, I've been using the Ergodox for 7 years now. And I mean, a lot of people don't like the Ergodox. I personally have been fine with it, but I think I'm ready for for something even a little bit better. Okay. So where do we get? We got to prepend and insert at. So if we go up here, we have everything done besides remove and remove at. Okay. So let me just think about this. Do we want to do remove or remove at first? Doesn't really matter. They're both going to use a similar helper function to move the elements around, like back in place where they were. Okay, yeah, that makes sense. So remove is really just a special case of remove at. As in, if we implement remove at first, we can get remove implemented pretty quick, kind of like prepend and insert at. So let's do that. Move this a little bit, helps the glare. Okay. I really should just get curtains for this room. Just, I don't know. It's work, man. It's work. You know? Okay. So we did remove already. What? I don't remember this. Oh yeah, remove is the thing at the end. Oh, that's really funny. I implemented remove as pop, and that's not the interface that they write to do on them. That's a good idea. I'll take that. So to do, do I want to put it above, before? I guess it doesn't matter. It's all a to do. What did I do? Oh no, I hit enter. Shit. I already did it. Oh, this is gonna go badly. Okay. So I hit to do. People who are just joining, what do you mean you hit enter? Like, yeah, what are you talking about? Okay, so what we actually implemented before was essentially pop. I don't know. I wonder what they call it in Rust for the vector. Should we just call it whatever Vec calls it, even though we implemented it ourselves? But since Vec is like the idiomatic array list, let's see. Rust pop, yeah, Rust pop. What are we on? Range? No, I want to go to vector. And yeah, this looks right. The thing I started getting a lot more anxiety about, like a little bit before the stream, besides, you know, just looking dumb as usual with the whole space and enter, is like doing a pseudo RM. I'm like not sure I'm gonna do that ever again at this point. You know, I'm too scared at this point to do a pseudo RM RF, and then, you know, I don't know, I start typing something and then I actually just hit enter instead of space. Way too scary. Of course it's a safe Poptroner. We only know how to write things in safe Rust. Okay. Alright. So let's see what we got. I don't think drain's gonna be what we want. So they call it append. What's append? Just out of interest. Is it basically concat? Yeah, it's concat. Okay. Cool. We have insert. It's not leak. No. They just call it pop. So they actually call it pop and push. Yep. There you go. Pop and push. How about that? Using names that people actually know. Very, very odd choice. I would have expected something more Fancy. All right. So we're going to rename our remove to pop, since that's what it really is. And then we're going to implement the remove item method. All right. I feel like I haven't coded in a long time, and that's not exactly true. I just, oh god, I had space again. Oh my gosh. I knew this was going to happen. I haven't coded since I started putting space and enter. All right, pop. How about it? Okay. Yeah, okay, sure. We'll just put it here. Chrome browser web app exploit. I know. Have I updated Brave or Chrome since I saw that? No, I have not. But it's a really good, it's a good call out. Everybody should update their Brave and Chrome. I'm just special. Yep, that was a space when I meant to hit enter. All right, here we go. So we're gonna say, yeah, it was a red update button. It absolutely was. We're living life dangerously. We're living life real dangerously over here at Teeny. If a little critical exploit is going to take down your application, I don't know. I mean, you're probably just not. It's probably a skill issue. That's a joke. That's a joke. Okay. All right. Pub function. What are we doing? What did we decide? Remove at. Well, I was happy that I hit a space, and then I realized, oh yeah, I don't need a space right there. Yeah, I don't care about CVEs, especially right now. No, that is what we want. Index, usize, and yeah, we can look at some holiday pictures, Teeny. Let's do it. Let's do it. All right. No, I get it. Dang it. I was like trying to be a nice person. I was like, hey, I'll see random holiday pictures. I'll do it. That's such. Oh God, I would have done it too. This is what happens. This is what happens when you don't pay for machines. You just don't care that much anymore. It's like you didn't pay for it, right? So, okay. Oh, that's funny. Fine, I will update. Okay, I'm not gonna update right now because then I have to re-import it to OBS and everything. But I will update it today because somebody's probably gonna do that on stream that isn't good-natured, and I'm going to totally fall for it because I forget things like right after, which means I'll probably forget to update. That's okay. It's okay. We live dangerously, You got to take risks. Very reasonable risks. All right. So let's talk about. I'm so distracted by that now. Because I know I would have just opened the image that Teeny sent me, and now I'm just like, oh my God, I'm so dumb. Okay. Okay. So good. Yeah, it's as long as I'm programming in Rust, I don't see how that exploit could affect me. All right. So we're going to remove an element at a specific index. So what are we going to actually do? And then return that element. So the first thing we need to do is find the element right at index, surprisingly. Then we're going to Shift, shift, what would that be? Shift left, all remaining elements, and then update length. I should just say decrement length. Why are we writing this in English first? I don't know. I don't know why we are. I'm just pretending that I'm not hitting space on accident, even though I absolutely am. Oh my god, no, I don't want that. Dang it, did they fucked up my config. Ah, I'm mad right now. Okay, I can live. I just have to press the shift key. I'm not going to explain what happened. It's just my keyboard config is not what I thought it was for my numbers, and it annoys me. Okay, it's okay. It's for my symbols. It's really what it is. I'm gonna survive. I'm gonna get through this. Just means I have to flash my keyboard again, which, to be fair, is not hard. It's all done very easily. Okay. Anyway, find the element at index. Do we know how to do that? All right. So the first thing we have to do, right, we want to do an optional. Almost forgot about that little guy. We're gonna say option, and we are gonna return the actual element, which means we're gonna have to clone it, right? We already know this. We already know we can't do this for real. We're just gonna have to clone that shit. I mean, if I did like a lifetime annotation, maybe I could make it work, but I'm not going to do that. Okay. Not yet anyway. This is still safe Rust, you know? It means you just clone shit. That's how you stay safe. Alright. Okay, so we have an option T. So our first check is going to say kind of like get below. I mean, we could use get if we really wanted to. No, I'm not feeling it right now. I'm not feeling it right now. We're gonna do this. If I is less than self.length. Oh my gosh, this space is killing me. If you did not hear my spiel before and you just joined, I recently switched my space and enter keys on my fancy split keyboard for better ergonomics, and it's not going so well. This is day one, basically day one. Okay, otherwise we just return none. Usually I would kind of like that base case, not really base case, but I would like it higher, but that's okay. All right, let's just do this, and here and there. Is that right? No, yeah, you did do the right thing. Shift left all remaining elements. We didn't even find the element at the index yet. I mean, I didn't copy this one down. Man, some days. Okay, if I is less than self.length, then we can actually just get the element at I. So we're gonna say, what did we call it everywhere else? Item. What a good name. What a great name. So let item equals, should be able to do this, self.length I, and we're cloning that. We're just cloning it right away. We already know it's not going to let us do anything else besides that. Self.length, what am I doing? Not self.length. Sorry guys, sorry. Oh, I hit an enter. Wow, this is going really, really fucking good. You can't find J, it's right there. We got J. All right. Shit show today. All right. Self.enter. I knew what I was doing. Oh my god, I did it again. This is so bad. This is killing me. Yeah, antivirus and Rust. Yeah, I mean, you wouldn't need, as long as you have the Rust, as long as you have Rust installed on your system, it works. You know, you don't even need antivirus. You just need Rust installed on your system. Are automatically fixed. You know. All right, self.enter I.clone. Yeah, we're doing this. We're doing this. I do have a confession. I can switch back to my old layer. I just added it as a new layer on my keyboard. So if this goes so badly and I just make mistakes constantly, I'm gonna switch back to space being where my brain thinks it is. And it has been for the last 7 years. Okay. So we're pretending I'm not gonna have to do that. I can bill more hours, it's true. Hey. It's funny. I used to do hourly and I was just so bad at it. I mean, I just hated it. It was not good for my mental health to work hourly. Like 1099 shit stuff wasn't good for me. That's what we call contractors, and yeah, like 1099 is the tax form if you're a contractor in the U.S. In case you don't live here in the States, the United States of America. Okay, anyway, so we have our item. We don't need to care that it's in there anymore. So we actually can just go ahead and shift everything left. So this is going to be similar to what we did before. The thing is, we don't actually have to start until our index, but we do need it to be inclusive of our index, but that's fine for our Rust range, right? So if we do this again, and we say for, dang it, I usually say item, right? No, it's for I. Okay, good deal. For I n index dot self dot length. So we only have to start at the index we're specifying. We don't have to shift everything in the array. You live in Europor. Is that the poor section of Europe? I mean, maybe poor is not a good thing to say anymore. I don't know. Europa. Hey, I don't know. I'm not gonna get into geopolitical stuff, but yeah. Oh, you just don't get 100K a month. Yeah, that's fair. That's fair. Yeah. The salaries are insane in the US. They can be. You know, granted, you know, depending on where you are, you pay for everything out of that salary, but the salary is still pretty darn high. You know, let's just hope I don't have, you know, any major health problem, and then I should be okay. You're right, Fortran. Here's 150K. Yeah, that's fair. That's totally fair code, though. Yeah. Man, it for a while, like, there was so many node jobs. Not at Fang. I'm talking about just like startup node jobs. Like, this was before the big layoffs and, you know, the market got a little bit tighter. But like in the US, it was like getting a job that paid 200 to 250 just at a smaller mid-sized company was like nothing. It was like, you know, as long as you have 5 years of experience, boom, you're done. So yeah, you'd still rather make less than 50 writing Rust. I could not live off of less than 50K. I mean, I know people do it somehow in Tennessee, which is where I live, but yeah, I get it. I get it. you know, I couldn't live, but you know, I also have a family. The audio goes out of sync the longer I stream. I was wondering about that too. It makes sense. As my computer gets more bogged down, the audio goes more out of sync. I did look, and it's still better than it was, but it's not like perfect. I don't know if it's ever going to be perfect as long as I'm streaming on an Intel-based Mac, and that's because you can't do, I think I already told Teeny this, but you can't do constant bitrate streaming with hardware encoding. You can't. Basically, I have a discrete GPU on my MacBook. It's not even being used. Not even being used for the stream at all. I have to rely completely on my CPU. It's really dumb. Really dumb. Anyway, yeah, you gotta buy that $10 coffee. Man, everything's crazy expensive out here these days. The economy. All right. Anyway, it's wild. A lot of people's rent has doubled, like just in the last 4 years. Rent has doubled. It's craziness. Anyway, for I and index to self.length, not including self.length, so we're good. We're good on out of bounds. I do not have experience in embedded at all, Copil, unfortunately. So if you leave right now, I'm not gonna be I'm gonna be offended. I'm gonna be sad, but not offended. How about that? Compromise. I'll still be sad, but I won't be offended. I think it would be really cool. I know a guy who does some embedded work. But not using Rust. No, he doesn't use Rust. So that does, you know. Hey, I know a guy who does embedded work. It's just sounded like the thing you say when you don't know anything about something. But yeah, no, it would be very cool to do that for sure. I think it would be a very cool thing. I'm sure you'd get. There aren't very many embedded streamers. Not to say that you're interested in streaming, but you know, Trotter, I don't know. What does that mean? You're gonna have to clarify, because it's feeling a little iffy. You're gonna have to clarify what you mean by that. Because it's feeling a little iffy. I'm guessing what you mean is there are a lot of people on YouTube that are doing embedded with Rust. We're gonna spin it to that positive side of things. I'm gonna guess that's what you mean. Oh God, I don't know, man. I don't know. Unfortunately, like I don't have special. I don't know why I don't have special privs to like. Just I could time them out. I'm not really gonna time you out, but I mean, like I could. I don't know how to just delete that one message. It's just different, Droner. I wouldn't use those words to explain it. It can, for some people, it can be hard to understand. Droner, come on. Don't make this worse. Don't make this bad. All right. I do not endorse the views of people in chat. All right. All right. For I n index dot self dot length. I know you mean you did learn from them, but like you just but I don't think you should say that somebody's accent is fucked up. That's all I'm saying. You should probably just be like, their accent is hard to understand, or sometimes the audio is a little unclear. You know, I'm just saying it's a little iffy. That's all I'm saying. All right. All right. One second here. Now I think we can do what we were gonna do originally, like before Teeny was like, you're just overwriting all your values. I think we can do it. We're gonna figure it out. Because we should be able to say like self.enter I, right? Equal. Oh my god. That's so bad. All right. Self.enter I. Oh yeah. No, that would be really hard. That would be really hard if like the title's in English and then the whole video is spoken in a different language. I think that would be annoying no matter what. I mean, it's got to be hard. I mean, I have a lot of respect for somebody that's having to speak in their second language, or, you know, most likely not even. I mean, that's a very American perspective because we don't learn languages. You know, if you speak two languages, you know, that's rare. If you're, you know, you're typical white American, but you know, you're speaking in a language that's non-native, right? And you're having to teach a concept, and you're trying to create content. That would be really hard. Yeah, exactly, Copill. Yeah, that's a lot. That's a lot to have to handle all together. That's a lot. You know, it's like, it's almost as if you switched your space and enter keys and it suddenly just broke you and you just weren't even able to write more than 4 lines of code in an hour. Okay, cool. So I think we can do this. We're gonna figure it out as we go along. We're gonna see if I'm right. I think I can do this guy and say I plus 1 dot clone. We know we're gonna have to clone it, right? We're not even pretending that we don't have to clone it. You know, if we had to clone it in, where is it? Where's insert at? Yeah, we had to clone it here. We're gonna have to clone it here. No doubt. Okay, so self.enter I equals self.enter I plus 1. Oh yeah, I saw a bug that I can't forget to fix. There we go. I doesn't even exist in that scope, and it doesn't even exist up here either. I'm being really good today. Really good. Okay. So, whoops, wrong way. When you have I doesn't exist, exactly. I mean, isn't that's deep. That's some deep shit right there, Copill. All right. If index is less than self.length, let item equals self.enterindex.clone. That seems right. For I in index self.length to self.length, self.enter I equals self.enter I plus 1 dot clone. We're moving everything over. In this one, Rust often makes me ponder the realities of existing. Rust is actually what we like to call a surrealistic language. There's not a whole lot of realism in the language. We mostly write Rust in order to continue to deconstruct ourselves in the process of failing to write software. Yeah, how about that? Good times. Okay, I think this will work. Let me just think about this. The only thing that doesn't actually get overwritten in this case is the very last element in the array. But technically that element doesn't, like, we're not even gonna pay attention to it. And we're not gonna pay attention to it because we're gonna decrement the length. Why are we gonna decrement the length? Why are we gonna decrement length? Oh my god. Fucking enter. Alright. Because that's the right thing to do. I don't know why I said it like 4 times. It's pretty fucking obvious why we're doing it. Alright. Self.length equals self.length minus 1. It's like I'm learning how to type all over again. Okay, just for switching space and enter, my brain is so fucked up. Okay. I can't even use Vim bindings. I can't do anything. All right, I did it again. Unbelievable. Okay, it hates it. It hates everything that I just did. All right, let's see what it's actually saying. Are you gonna give me an error, or are you just gonna continue to give me a red line? Insertion within the 4 keyword. What? Oh, it's just docs. Are you kidding me? Okay, there we go. Mismatch types. Expected enum option T found unit type. Yeah, it's because I didn't return anything. Duh. All right. So then we just say some item, and that's our return. I hit space again. Okay. Good times. Struggle. The struggle is real. Oh, yeah. No, I did this wrong. And that's because 5K. I should not have put this ampersand here. I did it. There, I hit enter. I didn't do :W space. Okay. It seems to like this. We'll see what happens. So I guess we'll test this first, and then we'll write out remove. Seems reasonable. So what are we gonna do? We're gonna remove that. So let's do l.remove at, should we just do 1 just because we have it right there and it's easy to remember? Sure. My brain feels like how I feel if I have THC, which is not great, unfortunately. It's like I'm paranoid to do anything and move it all, and I don't have a very clear idea of what's going on. This is what switching space and enter will do to you. All right, so let removed l.remove at 1. Okay, so we could do this. I kind of hate it actually. Let's change how. I don't like putting that on a different. Let's assert something else. We should actually have almost the same test as above. Could have probably just copied it and changed just the method call, but that's okay. We don't like doing things easy. Okay, so we're gonna remove that at 1. That looks fine. Emacs being slow. Emacs being slow. Okay. So we have that removed now. And so basically we want to see that our length is back down to, let's see, if it was 6 before, then we added something, then we removed something, we should be back to 6, right? So we should be able to say this is 6. Painfully slow typing. Painfully slow. Okay. And then we should be able to say, let's just check what the last element is, because I feel like that's what matters. It should still be 5. It should be 5. Right? We added something, we removed something, but we did it in the middle. So we should have a sum and 5 if we l.get l.length minus 1. All right. And nope, gotta press enter. Okay, let's test that. Oh, you hate the test I wrote. No method named remove found. Oh, I forgot about that whole little change up here. We need a test for the tests. You know what, Teeny, you're not wrong. Tests are only as good as the person who writes them. So what does that say about these tests? Not good things, unfortunately. Okay. We still don't like this? What don't we like? At 135, the 13 down? What don't you like about this? Some value of type T, mismatched types, expected option. Oh, yeah, okay. Nope, that's on me. Nope. There we go. Okay. This seems fine. Yay. Looks fine. Okay. Do we know for sure that it's fine? No, of course not. We don't know that it's fine. It just looks fine, right? Okay, so let's do this. Let's do remove, and then we'll do a debug print, and just walk through it. Make sure we did everything that we were supposed to do. Fucking brains. Brains are so dumb. Anybody else hate brains? I do. Item T. Let's see. Do we want a ref to T? Okay, so you have an item. It's a really weird method in one way. It's like I just got this item out and I want to remove it. I guess if you called get and then you called remove, I guess. So in that case, I think we want to call it we want a reference to T. And if you already had T, you already had a reference to T, so you know what the value is. So do you really want the T back? Feels a little bit odd, right? Feels a little bit odd, but we'll do it mostly because we also want to support the none case. You could, like, let me think about this. I mean, realistically, if I would want to return a result, because I want this to error. I don't want this to error. I don't know. What's a good API? What's the TypeScript API? Because we know the TypeScript API is going to be so good. And by TypeScript API, I don't really mean something that's built into TypeScript. It's just what we're basing this off of, which is an open source TypeScript implementation of some of these things. Yeah, this is test-driven test development. Yeah, TD. There's a lot of TDs around there. Yeah, couple streams ago, I labeled my stream writing tests after code to trigger Uncle Bob. I was pretty happy with that title. I thought it was pretty good. But, you know, that's just me. All right, so we're doing remove. Okay, it still does return the type in this. So we'll keep going with that. That's fine. Let's return the type. I guess the one thing I can do is actually, well, I'm just going to return what remove at does, right? That's all I'm going to do. Like, do we have an extra check with the whole index is less than self.length? Like, yeah, but that's a very cheap check. So I don't feel bad about using that for the implementation of this. So what are we gonna do? Remove at already does our index check, but we actually have to find the freaking index of this thing. Like, so, I mean, again, it doing the index check doesn't help us at all, right? We have to make sure that this item actually exists here, otherwise we return an option. Now, of course, like in a normal land, I would be able to iterate over this with like a nice iterator or something, but we don't have that. We're pretending we don't anyway, so we're gonna go with our for loop again, right? And we're gonna try to do an early return from the for loop if we find it. I'm pretty sure that works in Rust. I've never done it before, but I'm guessing that works. So if we say 0.self.length, and you actually don't, let me think why I'm doing this. I was gonna say, we, like, a lot of times people would just do for item in self.inner, you know, and then just get it there. But in this case, because our inner is could have more elements than our actual data structure elements, then we do it. You can use goto. I don't know what you mean, Deanie. You're smarter than I am. All right. It's a joke. Okay. Yeah, you just use goto, right? It's a goto joke. I got it. I'm with you. All right. I just assume, I pretty much always assume I'm doing something wrong. So, you know, it's a pretty fair assumption. Okay, so we have for I and 0.2 self.length again. Ranges aren't inclusive in that syntax, so we're not going to include that last one. And we're going to say something simple like if self.inner I, oh my god, killing myself. All right, self.inner I, it's simple if you know how to type a space. Self.inner I equals, might want to double equals there, equals item, right? Then we want I wish I just had something pinned that was like, I switched my space and enter key. I'm not actually this bad at typing usually. People who have watched the stream before might disagree. All right. Self.inner I equals item. Then we're going to do an explicit return, which Prime does every time when he writes Rust because he's a boomer, just so everybody knows. All right, self.inner I equals item. Then we're going to return. Do I want to do it this way? Let me just feel this for a second. Yeah, still think I want to do it. I think we're still going to do this. We're still going to do a little self.remove at I. All right. So we have that. And then outside of our for loop, so right here, we can actually just return a none. So let's see what we did wrong. I can't remember if I'm deriving, I might not be deriving partial equals here. It's reasonable. You have to have an equality check if you want to use this. So we're gonna have to allow, we don't have to derive it, but we have to further, my brain is so fucked right now. We have to further narrow our type, right? By saying it has to be a partial eq. Partial eq. All right. Let's see. Where were we? We were down here. Okay, so we got through one thing. Self and mute ArrayList T. Right, so that's a T, and that's not a T. So usually we'll just do a little bit of this, and that will get rid of that. Let's see. Self.remote at. Wow. Who saw that? Who saw that before me? All right. How about that? Is that better? Okay. Self.remove at I. Are you happy now? You happy now? All right. Let's just go down to our tests. We're going to pretend it's happy. And let's see. What are we doing? I already forgot what we just actually... Well, we removed an actual item, right? So what do we have? Right now, I know we're going to have a 3 in here. We haven't removed a 3. So let's go ahead and remove 3. So we'll just say insert eq sum 3 l dot remove and 3. Okay. Do I say and instead of ampersand? Yeah, I do. Okay. It's just how I do. All right. So I think that's good. And then after we've removed that 3, we should be able to say, let's just do this real quick and put something we know doesn't exist. Because we're making these tests like so good. These is like a very, very robust test suite. All right, insert eq. Let's do one more. Let's just say that our length is 5 now, if I remember correctly. And then we'll do, if these pass, we'll do an assert false so that we can see the debug print after everything. Make sure that our tests are sufficient. Because that has been a problem in the past. Isn't that surprising? Okay. Nope. There we go. All right. Hey, look at us. Look at us. How far we've come. The only problem is I don't have a debug print on this method yet. So I need to add that. Not bad. Hey, Runic, what's up, man? How are you? We're just writing some array lists in Rust right now, you know. How's your project gone? We did remove. What was it? It was remove, right? Yeah, let's look at it. Let's do remove at because we use it every time. It's like this, right? I think that's right. Looks right. Nope. Because now I'm not returning the right thing. Michael, what are you doing? What's wrong with you? All right. Let's just put it up here. What? Oh no, that won't work either. I have to put it another thing up. My fault. My fault, guys. You know, we know what this is. We know how newbie I get. All right, that should work. Scatterbrain went back to Rust today. Sweet. Did you stream today or just work on it off stream, as if that's a thing, as if someone could actually get work done off stream? That's not a thing, right? Okay, so it failed, but we did that on purpose, right? We didn't assert false. I didn't mess anything up. Okay, so we appended 1 to ArrayList 1. This looks good. We got 1, 2, 3, 4, 5. This looks good. We added our -1. Here, we'll get our tests. Okay, so -1's where we just got to. We prepended 1000. Yep, so we're at 10 up in the frame above, buffer above. Then we inserted 2000. Then we removed 2000. And then we removed 3. I think this looks good. Dude, genetics is a really big topic. I mean, trying to figure out genetics and trait bounds, I don't know if I'm even close to that. I know you meant generics, I'm just being a jerk. Yeah, for sure, man. Okay, so I think that looks pretty good. Let's make sure we didn't like introduce a regression. We did not. Our tests still pass. Not bad, guys. We have what is, according to my tests, a working array list. Written in Rust, kind of faking it a little bit because we used a vec under the hood, which is of course just a thick array list, a thick abstraction on top of an array list. Yeah, trying to learn more about generics and trait bounds and finally get confident with lifetimes. Yeah, I did like my first lifetime annotation in the open source thing I did, it was probably only like a week ago. I don't know, I can't remember. I'm bad at time. That was interesting, but the compiler basically told me exactly what to do and it made sense, you know? So that was nice. Now, if I knew more about lifetimes, could I have made this implementation better? Probably. All right, so I guess we should get rid of our debug calls at this point because we know this works. And because it's written in Rust, what do we know? We know that it's bug-free, right? All code written in Rust is bug-free. Isn't that correct? Okay, that's a joke. All right, why didn't it show me this one? Apparently you can do cargo test, show output, and don't. Yeah, I bet that's true. Since I was using keyboard shortcuts within Emacs, then I would have had to do something really hard, like go over to my terminal, which is currently just a nice blank square in my upper right. Yeah, good call out though. I knew that existed, but not the actual syntax for it, Teeny. All right. This looks good. So the fun part today, Runic, is, if you're still here, is that I switched my... Yeah, this is Emacs. It's evil mode, though, so it makes everybody mad. If you have Emacs and evil mode, everybody's upset. It's the only reason I do it. I don't care about the tools. I just do it to make people mad. But anyway, I switched my space and my enter key on my split keyboard, and you know, I've had this config for 7 years, and now it's going pretty bad. Classic Englishmen declaring war with an American. Classic. Cool. So our tests still pass. Let's go ahead and use your mouse. Can't believe you even have a mouse. No, I'm just kidding. I use a mouse often when I get frustrated with things. Okay, so I haven't done a commit in a while, I think, right? Yeah, just since we did new, append, remove, and git. Okay, so we did a lot of things. ArrayList, finish, fake, ArrayList. Simple. How about that? Fucking Hitler. All right, push. All right, cool. So all that code is up on the GitHub now, which is pretty cool. We did our array list using the vector underneath, which isn't so bad. I don't know. What do you guys think? People who have been around here for most of the time. Was this terrible? Was it? Do you have any questions about array lists? I don't know. I you know, we finished it, which, you know, it didn't take an insane amount of time. I feel like I could whiteboard this as, you know, fake. I was hoping nobody would mention the unsafe code, okay? Yeah, this is a fake array list. That's why I kept using the word fake, right? It's just using an array list underneath an array list. We get it. We get it. But what did we say? We said we were going to try to do it in unsafe, right? And actually use a real array and figure out a way to do this. But then we read that whole thing about how maybe what we want is just a box slice. And then we don't even have to worry about the unsafe array stuff. So I don't know. I don't know what's worse. So I'm unfamiliar with both of those concepts. So they both have value. It's basically how it goes. I feel like we could go one of two ways, right? We could either copy over this implementation or just refactor it in place to use a box T. We could have that as a separate implementation, or we could move on to a different data structure and then like try a box slice on a new data structure. And to, oh my god, I did it again. To remind everybody, this is the list of, oh no, the VLC thing happened again randomly. Why does it do this? It randomly switches views and then it fucks everything up. Really annoying. Really fucking annoying. That makes me so mad. Oh well. Oh well. Okay. I don't know what triggers that, but I'm also using a really buggy version of VLC. So that's how it works. Do you have to use unsafe? It's a good question, Mr. Elfman. Welcome in. You practice unsafe vex all the time. I'm glad I read that before I really got what you're going there for. Ruining. That's good. Yeah, we do a lot of unsafe vex in Rust. Yeah. So in order to, how to explain this? Okay. So basically, let's go over our implementation as a wrap up, right? Right now, what did my fake array? You've never written DS in Rust, so I don't know if unsafe is required. It is mostly required. I will put it that way. As a short answer, mostly required as far as I can tell. Yeah, pretty much. Oh yeah, thank you. So here's our ArrayList implementation that we just finished. So what did I do? I just new typed vec as array to make it a pretend array. But really I'm just using vec as my underneath. Typically you'd use like a real array, right? That contiguous memory chunk. I can get to that, Mr. Elfman. So our main ArrayList struct, it's a generic. We're deriving debug just to make logging nicer, so we can log it out. And we have length, that's a public property, so users of this data structure can read it. And then we have a private property on the struct or field, inner. And that is essentially our array, in this case, a generic array. So then we actually import our methods down here for our array list. As we were going through it, maybe you can get away with not doing this if you're using unsafe, but at least the way that we had to implement it, we needed debug. That's really just for printing. It's not hard to implement debug. It's a pretty reasonable thing. Like, would you actually log things out if you implemented this data structure? No. Like, so you could take the debug off. And then default, that's also part of our implementation. But I would say even if I was using a real array underneath, I would still need the default trait. And then we have clone, that's just so that we can get around some of the borrow checking problems. And then partial eq is pretty much required because of our remove item. And our remove item uses an equality check. So that's pretty much going to be required in any implementation with this particular interface that we decided to do. So yeah, so in our constructor, we create our new ArrayList struct. We initialize it with a length of 0, and we just use a default inner of 5. So an array of, you've seen config specific attributes. Oh, that's very cool. So you could just do like a debug thing. Yeah, that would be very cool. So yeah, so we initialize our inner array as 5 elements using the default trait. So this is what we get. That's part of why default. Here we're using the vec macro because, again, it's just an actual vec. The one thing that I like about this syntax, though, is if we are to use a real array and initializing it, it's almost this exact syntax to initialize an array. So in that way, it's nice. Okay. Grow inner is a helper function that we'll see below. So our append method, it's this guy right here. We're just adding an item to the end. It's pretty simple. We make sure that we have enough capacity on our inner array. We open it up, make sure that we have enough, we grow it if we don't, and then we just add our item to the end, not to the end of the actual inner array, right? Not to the actual array, but to the length of our data structure. So, remember, you have to keep those two things separate in your head we have our capacity, and we have our length, right? If you used a real array, you'd have to use unsafe to resize its capacity. Yeah, so the main problem, the main reason that I can't in safe Rust just put an array in here, there's a couple problems with it. Problem number one is that an array's type is actually sized, right? So if we were to do something like, say, enter, wait, no, it's not here that I would care about it. Here, I will show it in the type. So if we wanted this array T here, and if we wanted to replace that with a real array, then we would be doing something like this. And we would say T. Oh my God, sorry. If you haven't been here long, I switched my space and enter keys on my fancy keyboard, and so I messed it up. So technically this is the type of an array, right? But it has the size, and the size has to be known at compile time in order for it to be like an actual array. We don't have possibility of boxing it. So what I don't actually know is in unsafe code, like how I would actually type the struct. And that's part of what we were going to discover in the unsafe implementation, right? And then you'd have to then figure out a way to express, I've got this array, you know, otherwise your whole, I don't know if your whole type ends up being unsafe or what. I don't actually have any clue how to do it, to be honest. I'm a noob, man, you know, been writing Rust a couple months, maybe. Yeah, I mean, essentially these are things that you quote unquote shouldn't have to do, right? Like if you really want an array list, you probably should just be using a vec, right? Like implementing an array list in Rust, like using safe code, is pretty hard. Now, what I read, and there was a great article about this. Let's see if I still have it up. If I do, I'll post it in chat. Here we go. Great article about DSA and Rust, in case you're wondering. Yeah, so it's essentially explaining what I'm talking about right now. It's mostly where I got most of my information from it. But one of the suggestions, which is here, is oh, I thought I was at the exact same spot. No, this is the right spot. So basically what one guy suggested, this excess guy, is that we just use a box T. So that is an interesting way. I already can create a box T, which is, this is just box of slice T, basically. That's what I'd use if I was building a data structure and didn't want vex unnecessary baggage added to the mix, right? So if you wanted to implement it, great, directly. I would just end up writing C++ code if I got to use unsafe. Yeah, I mean, I get it. I'm not like a full-on Rust Andy, right? But like, I think the thing that they tried to make the point of, whether it's valid, like whether it's enough for you or not, is that, yeah, we can use unsafe bits here and there, but we should be able to have like a safe wrapper on top of that, right? So I think that's interesting. So I'm probably not going to go too much longer. I'm thinking maybe if it's interesting to people and what I'm interested in is actually looking at Vex implementation. in the standard library, because that also might answer some of our questions. You want to get GC instead of borrow checker. I mean, the borrow checker is, to be fair, a little bit what? All right, let's go back here. The borrow checker is can be annoying, no doubt. But I don't know. Has its uses, has its benefits. I think as somebody that has not done a lot of systems language work, I think it can be a helpful guide, and it's helpful to understand how pointers work. But do you really want to be constrained by the borrow checker all the time in every program you write? I don't know. Sounds pretty rough. Okay, so here's our impl of vectee. Okay, so what do they use? Okay, they use a raw vec. All right, so their buff underneath is a raw vec. Yeah, I've never used Swift, so I don't know. I try not to opine on things that I haven't used extensively. I've been on the JVM professionally at work for 10 years, and I fucking hate it. So, you know, like as far as garbage collectors go, it's not something that like I have like fond feelings for per se. But of course, you know, it's not to say that every single garbage collected language is terrible. But you're saying it just uses shared pointers everywhere, RC and ARC only. Yeah. Interesting. Okay, so let's see how they implemented vec in the standard library. They have, you know, pub struct vec, very similar to what we have, a buff and a length, right? I think they just say buff and len. They just make these private. Technically, you have to call the len function, the len method on vec in order to get the length. We just made the field public because why not? I mean, I guess the reason why not in general is technically what you could use a mutable. If you got a mutable reference to the vec, then you could change the length, I guess, yourself. That's probably why not. We're not worrying about that. We're pretending that's not possible. All right. So yeah. So then they do the impl of vec, they have a new, and they have raw vec new. So of course this begs the question, like, what the heck is a raw vec, right? I wonder if it's in this. Let's see if we can actually find that. Can you look up raw vec in docs? Yeah, I know, right? No, that's totally something that somebody would do. I mean, that's the real, I mean, if you were writing this for real, yeah, like that's why not. But nope, you just have to find it in the source code. I will say the only thing that bugs me a little bit is when you go to source, it opens this like weird rusty source code thing. And I kind of just wish it opened it up in GitHub. I mean, the good thing is this is off my file system, which is nice, but I still kind of wish they just, yeah, they are also using a fake array. No, it's true. They're not even using a real array per se, right? It's this raw vec, and I don't know what it is yet. I don't know what it is. All right, so let's just see if there's, if we can look at, okay, with capacity, we decided not to do, but you know, it's a nice helper function. I think we'd understand exactly. It wouldn't be hard to implement in our array list, obviously. Like we just use the default capacity of 5. That's just a matter of, you know, specifying the initial capacity. This says from raw parts. Wow, look at this unsafe function from raw parts. Oh my god. Okay. Okay, so here we go. It's so thick that like looking at this is probably going to annoy the shit out of me. So again, they're using this raw vec thing a lot. Let's just see. So unsafe empl drop for vec t, drop for t. Use a raw slice to refer to the elements of the vector as weak as necessary time. Okay, raw vec handles deallocation. Interesting. Whoops. That's in crate raw vec. Okay, got it. So we actually are going to have to go into the. You found the docs. Look at you. Look at you, Teeny. You're just always on top of it. When I give up, Teeny just pulls through. All right. So let's look at how raw vec is done. So it is public. Why didn't it show up in the docs for me? Am I dumb? Did I type it wrong? What is going on? No, it just doesn't show up. Dumb. Okay, so this is what they use. A low-level utility for more ergonomically allocating, reallocating, and deallocating a buffer of memory on the heap without having to worry about all the corner cases involved. This type is excellent for building your own data structures like vec and vecdq. Well, maybe, can we just use this? Can we use a raw vec? And then we don't have to actually worry about it? Now, the only thing is, let's see. So it has a pointer, right? I don't know. I actually have no idea what unique is. TBH. I have no idea what unique is. Where does unique come from? Core, pointer, unique. Okay. Okay, so it's like it's specifying a certain type of pointer, I would guess. usize alloc a. Okay, so let's see how they do this. Okay, I feel like most of these comments are for the actual language maintainers, but I could be wrong. Yeah, that's a language maintainer comment. Interesting. Creates the biggest possible raw vec on the system heap without allocating? If t has positive size, then this makes a raw vec with capacity 0. If t is 0 size, then it makes a raw vec with capacity usize max, useful for implementing delayed allocation. If I understand that right, that's kind of surprising to me and kind of weird. Am I understanding that they're just going to create? So they're going to create the biggest possible raw vec in heap without allocating. Interesting. Okay, that's kind of weird to me, but that's okay. They're smarter than me, probably. They at least know more about this than I do. Okay, so creates a raw vec on the system heap with exactly the capacity and alignment requirements for a t capacity. This is equivalent to calling raw vec new when capacity is 0 or t is 0 sized. Okay. Okay, got it. What would a 0 sized t be? I don't know. Like with capacity, but guarantees the buffer is zeroed. Okay. Let's see if we understand anything that's happening right here. So impl ta allocator raw vec ta tiny vecs are dom. So I don't understand if this is a public, maybe it's not actually exported. Can I use a raw vec? Can I call raw vec new? Where is this? Where does this live? Feature equals raw vec internals. Oh, I see. So I would have to, that makes sense. So I'd have to say I want the rawvec internals feature, and I'm okay that it's not stable, because basically they want to be able to change this inner implementation. So if you wanted to depend on this, it doesn't have the same stability guarantees as the rest of the language. So that's why they're not going to suggest it to other people. Okay. I'm not sure if I'm actually gaining anything from looking at this yet, because I kind of just expected them to do something special with an array, and so far that's not what they've done. I think my partner might be home. Let me see what is going on. Okay, whatever. We'll see. Yeah, that's why I guessed that they were home. Converts the entire buffer into box, maybe on init t with the specified len. Okay, so into box, that doesn't, I don't care about that. Allocate in. I don't know if I'm actually gaining anything from reading this right now. It might just be because I'm tired. From a pointer, capacity, and allocator, or it's just like it's so in the weeds for me that I'm not getting the point. Capacity of the allocation returns a shared reference to the allocator backing this rawvec. Okay. And that's the allocator type is A. Let's look at the struct again. Alloc is A allocator equals global. So it's a type of allocator which is in another part of the code base. That's what I mean. Like, I think this is too, it's like this isn't something that's actually helping me, because it's like it doesn't help unless I read every single one of these things to understand how they got this allocator. So I think this is why I'm not getting a lot of value out of this. Hi Imra, what's up? How are you today? Okay, I think I'm done reading this. I was hoping that I could get like something really good out of this, but I don't think I'm getting there. I don't think it's really helping me. Layout, array, T, cap. Yeah, that's what I mean. So they got this like finish grow, new layout. Yeah, like this is just, it's too much. Thank you, Imra. I do appreciate that. Beard compliments are always welcome. You know, it's part of the stream. It's an important part of the stream. I don't know if you can really code in Rust if you don't have a beard. No, it's, let's be fair. That's probably more like C++, right? I mean, Rust is blue hair, right? We all know that. Well, guys, I was hoping this rawvec would just be like this light bulb moment for me, where it just be like, that's how it works. I get it now. I understand exactly how I would implement this. But let's be real, the people making the language have built up all these other abstractions that they're building on top of, which makes sense. You know, they have helpers in order to do memory allocations, all those kinds of things. Rustonomicon. Okay, we'll look at this teeny, sure. It better not have an image. I didn't update yet. We're gonna write std vec from scratch. We're going to limit ourselves to stable Rust. All right, this will be cool, actually. This will show us, like, compared to somebody who probably knows Rust really well, like, what were we so... I mean, look at this. Ultimately, this means our implementation may not take advantage of all possible optimizations, though it will by no means be naive. Yeah. All right. All right. I like this. Okay. Okay. This sounds cool. Let's do it. Let's do it. I think this is more what I'm actually looking for. If you are hanging out, you're following, I do write code. I promise. I promise I write code. We just wrote code. Okay. We spent an hour watching me. Thank you, Igumus, for the follow. I appreciate it. I wonder if they do it for other types. We're gonna have to look. This is cool. I don't think I've looked at Rustonomicon before. I've usually used Rust by example or the book. I don't think I've actually looked through this before. So thanks, Teeny. We do write code. We're working on data structures. We just wrote what I would call a naive array list. It's on GitHub if you care, if you even care. Here, let's see, we pushed it, right? Did we push? Did we remember to push? Let's see. Finish fake array list impl. Yeah, we pushed it. Here's the code we just finished writing. You know, share it on Twitter, share it with all your friends, let them know that it's just really effing good. Just kidding. Don't do that. I would probably get a lot of comments about how bad my code is. But yeah. Okay, cool. So let's look through this a little bit, and then we'll probably leave it for another day. I'll also do a little bit of this. If you're more of a YouTube person or whatever, I don't know why you would be. Why would you like YouTube? I don't know. No. I have a new channel. Yay. So there's that. And then previous videos you can watch here on Twitch. I do just keep the VODs up. Or if you want to, you can watch them on YouTube. Up to you. They're all there. There's only 3 of them. Okay. First, we need to come up with the struct layout. A vec has 3 parts: a pointer to the allocation, the size of the allocation, and the number of elements that have been initialized. Oh no, what? No. Did I? Might want to close the sidebar. Oh, okay. Okay. Yeah, that's what I was actually just thinking about that as I was looking at the screen. Let's see. How do I close the sidebar, Teeny? I don't understand. Okay. That's still pretty bad. Can't I just... You guys can kind of see more of it. Here, let me see. Let me see if I can make this better. You'll have to deal with the black bar on the side of the screen, but it's probably better that you can actually read the text, right? All right. Better. Okay. First off, we need to come up with the struct layout. I don't think we need to read this word for word. We already kind of know what's going on. Okay, so we want this design. We want a pointer to a mutable t. Okay. We have the capacity. I get that. And then we have the len. Interesting. Not how I would have expected. Let's keep looking at it. This would compile. Unfortunately, it would be too strict. The compiler will give us 2 strict variants. So a &vec &static stir couldn't be used where a &vec &a stir was expected. Okay. As we saw in the ownership chapter, the standard library uses unique t in place of mute t when it has a raw pointer to an allocation that it owns. Okay. Let's think of, we saw that, right? When we read the vec implementation, this was it. They had this unique t instead of this star mute t, which star is just deref, isn't it? So I don't know what this actually, what does that mean in a type? What does star mute mean in a type? I don't know off the top of my head. So let's find out. Because GPT knows everything. It didn't lie to us like a mother the other day. Oh no. I forgot about the space and enter thing. I just put in like 4 different queries. Okay. Page unresponsive. Are you kidding? Are you kidding me right now? Oh my god. Is this gonna take more time than just like Google? Don't you hate that? Don't you hate when ChatGPT actually takes more time than Google? No fun. No fun. Okay. Finally. What? That's great. Okay, what does represent? Okay, let's just try that. Okay, let's see. Okay, create a raw mutable pointer to X. I thought raw pointers weren't possible outside of unsafe. Isn't that what we read? Oh, yeah, it's right fucking here. Okay, so this is interesting. That's kind of one of the questions I had, right? Is like, how do we even type this if we have to use unsafe to access it? So if GPT is right here, we create a mutable value. We create a raw mutable pointer to that value, and then we can actually deref it inside of unsafe and modify that value. Okay, okay. I think that's interesting. Let's go back here. I might have to leave before we can finish this. Okay, as a recap, unique is a wrapper around a raw pointer that declares that we are covariant over t. We may own a value of type t. This is not relevant, for example, here. Why the real std vec needs this. We are send-sync if t is send-sync, yeah. Our pointer is never null, so option vec t is null pointer optimized. Okay. Interesting. So it can't be a null pointer. Okay. We can implement all of the above requirements in stable Rust. To do this, instead of using unique, we will use non-null t, another wrapper around a raw pointer which gives us 2 of the above properties, namely it is covariant over t and is declared to never be null. By implementing send-sync, if t is, we get the same results as using unique t. Okay, that's cool. Okay, so pub struct vec t, and then we just have this non-null. So I think that's the thing. Never even looked at this part of Rust before. It's these different pointer types, basically these pointer wrappers. These wrappers for raw pointers that you would have to use. Using non-null throws a wrench in an important feature of vec, and indeed all the std collections. Creating an empty vec doesn't actually allocate at all. This is not the same as allocating a zero-sized memory block, which is not allowed by the global allocator. It results in undefined behavior. So if we can't allocate, but also can't put a null pointer in pointer, what do we do in vec.do? Well, we just put some other garbage in there. That's what we did. We just put garbage. See, we know what we're doing. All right, this is perfectly fine because we already have cap equals 0 as our sentinel for no allocation. We don't even need to handle it especially in almost any code, because we usually need to check if cap is greater than len or len is greater than 0 anyway. The recommended Rust value to put here is mem a line of t. Okay, this is pretty in the weeds. This is like, can you imagine like knowing that that's what you need in a whiteboard interview? Yeah, of course, we're just gonna do this mem a line of t right here. That is not something I can imagine remembering in a whiteboard interview. Non-null provides a convenience for this non-null dangling. There are quite a few places where we'll want to use dangling because there's no real allocation to talk about, but null would make the compiler do bad things. So use stdmem, impl for vect, pub funct new self. So here's our constructor. We have an assert that says we're not going to handle your ZSTs. Don't even freaking try. I slipped in that assert there because zero size types will require some special handling throughput our code. Okay, thanks. And then we create a vec. We have a pointer that's non-null dangling. You got a little dangling pointer with a len and a cap of 0. Okay. Yeah, with 2 months of Rust, this is not something that came to my head as how to implement an array list. I slipped in that assert there because zero size types will require, I already read that. Next, we need to figure out what to actually do when we do want space. For that, we use the global allocation functions, alloc, realloc, and dealloc, which are available in stable Rust in stdalloc. These functions are expected to become deprecated in favor of the methods of stdalloc global after this type is stabilized. I don't know if it's stabilized yet. We'll also need a way to handle OOM conditions. Okay. Yeah, most platforms don't actually run out of memory in a conventional way. Okay, now we can write growing. Roughly, we want to have this logic. If cap equals 0, allocate. Cap equals 1. Else reallocate cap times equals 2. I mean, of course it's multiplicative, right, Droner? Are you still here, Droner? I mean, who the heck would just add capacity? Like, who would use an additive operator to add capacity in an array list? That would be ridiculous. I definitely wouldn't have. All right. But Rust only supported allocator APIs so low level that we'll need to do a fair bit of extra work. Okay, let's try to figure out a place to wrap up because the fam is on the way home here. In particular, pointer offset will cause us a lot of trouble. I think this whole thing is causing you a lot of trouble. You know? I mean, to the point, if we were writing C or C++, we would have been done. We would have caused a lot of seg faults. It would have leaked a lot of memory, but we would have been done. All right. As a simple example, consider the following fragment of code. Okay. Okay, wow. Yeah, this is pretty advanced. All right. So here's their grow function. Let's just look at this grow and then we'll call it a day. Let me just let my partner know that's what I'm doing. And I just sent one-word messages, sent 4 messages. Very good. Love it. Okay. Use stdalloc self layout. Impl vec for t, basically, right? So they're grow. So this we ended up just putting inside of our. No, we have a grow. We have our grow inner, right? So we have grow inner. So we did a very, non-performant grow inner. Here. And we got this, right? We cloned everything. We multiplied the inner capacity by 2. We did all the right things. This is still O of n. It's not the worst thing in the world, you know. Grow inner is gonna be, it's gonna be O of n in general. Well, I mean, in this case, with a mem copy, I don't know if you'd consider that an O of n. I would say you probably would not, right? Anyway, okay, let's look at this. So we grow. New cap, new layout equals if self.cap equals 0, 1 layout array t1.unwrap. Interesting. So I guess if you start with a capacity of 0, they only give you a capacity of 1 the first time. It's an interesting choice. I guess it makes sense in the way that, like, it's very cheap to do a mem copy of one element onto a new array, right? Or a new buffer or whatever you're using underneath. Okay. This can't overflow since self.cap is less than isize max. Let new cap 2 times self.cap. Yep. Layout array checks that the number of bytes is less than usize max, but this is redundant since old layout.size is less than or equal to isize max. So the unwrap should never fail. Okay. So you have layout array again. I guess this, okay, so these are helper methods that Rust provides in std.alloc layout. Very interesting. Maybe that's something we can look at next time. New cap, new layout. Ensure that the new allocation doesn't exceed isize max bytes. Sure. Let new pointer equals if self.cap equals 0. All right, Runic. Thanks, man. Thanks for hanging out. Come on, isn't this like helping you go to bed? Yeah, you're fine. Okay. So then we have let new pointer equals if self.cap, that's capacity again, right? Equals 0, unsafe alloc. So it's basically saying if our capacity was 0, we're now actually going to allocate in memory the thing. Before we weren't, right? And then else let old layout equals layout array t self.cap.unwrap. Okay. So again, the old layout, that's just our old self.inner basically, right? Am I like 100% sure how the heck this works? Not really. To be honest, I don't really know. Okay, I guess we have the pointer here, right? We have the pointer to the actual memory address. Okay, self.pointer as mute, and remember this is our mutable reference to a raw pointer, unsafe, and then we're going to realloc old pointer, old layout, new layout dot size. Interesting. So that's pretty nice, honestly. Like, that's not bad. This isn't bad. So I don't know if the guy's still here that was like, I can't believe you can't do this in safe Rust. It's like, I kind of get it, yeah, but like, you have this one unsafe block and you're just calling this realloc code. I mean, it's not the worst thing ever. You still have the safety guarantees everywhere else besides right there. I don't know, not so bad. If allocation fails, new pointer will be null, in which case we abort. Self.pointer equals match non-null new pointer as mute t. Yeah, some pp, otherwise. Right, and this is self.pointer, right? Is an optional. Okay, I didn't remember pointer being an optional. Was it? Where's my struct? I want to see my struct on the same page. Okay. Let's just look at that real quick. It's not. It's a raw t. So why do you self.pointer equals match non-null new pointer as mute t some. Oh no. Okay. Nope. I'm dumb. I wasn't reading the match statement close enough. right? So it's just that this non-null new returns an option, and that's why they're pattern matching on the sum and the none case. Okay, I'd have to read most of what this means to understand actually how that works, but you can kind of get the high level of what they're trying to do. Whether or not you like completely understand how it works and I would know how to go implement it. This is a really cool resource, Teeny. Thank you. Thanks for sharing that. I think that could help us if we want to go that route. You know, I don't know. Maybe it's something worth looking into next stream. I'm willing to consider it. So yeah, if you're hanging out and you don't follow, we're doing Rust data structures and algorithms, and we just finished our array list using a vec underneath. I know, a little disappointing, but we'll see if we want to refactor that, or if we just want to move on to a new data structure and try using something besides a vec underneath. So that's kind of what I'm doing. Appreciate everybody that hung out. I'm glad I could just fit in a couple hours of streaming today. I most likely will be streaming tomorrow, depending on how everything goes. But I would say more definitely Monday, but most likely tomorrow. We might just do some reading. We might just kind of like, I'll probably do a little bit of reading off stream and then see if I can understand some of this so that we're not just spending 2 hours reading. But yeah, I hope this was in some way entertaining. I learned some things. I'm glad we finished our array list, and that felt good. And again, thanks for everything. And I think we're good. I don't think I have time for a stream today. I mean a raid. So yeah, we'll just end it there. See you guys.